first sequence of gameplay that we're going to control via the level blueprint involves the player's search for the foreman's keys in one of the three worker houses here on 6A, 6B, 6C. And the last place they look is where they'll find the keys. So we need to set that up in the level blueprint. To open up the level blueprint, we just select the level we want to do our scripting in. For us, all the level design stuff, actors and scripting is in this level here, Milltown_LD. So we'll click the little gamepad icon to open the level blueprint. And the first thing we're going to need to do, if you recall, we actually placed three different instances of the keys in these houses. So we need to hide them all at the start. When the player does three different searches, we're going to reveal the keys at the particular house that they're searching in. So let's go here. Let's actually use the event begin play. And first I'm going to go to the world outliner. It's probably the easiest way. I'm going to grab these three key references here. So they're all selected. I'm going to go to the level blueprint and I'm going to right click and look for references. Create references to three actors. And this is the great thing about the level blueprint is it creates this direct connection between actors in the world and the level blueprint where you can do your scripting. So at the start of the level, we're going to hide these. So we'll look for set actor hidden in game. We'll connect all these to this. We'll set hidden to true and connect this function to event begin play. And also, since we don't want the player not only not seeing these things, but we don't want them to inadvertently bump into them or interact with them because of their collision, we're also going to set actor enable collision for each of the three instances. So we could have made a function probably in each of these actors that does the same thing that makes them completely invisible and uninteractable in the world. But since we didn't, this will do the job for a simple prototype. And let's just comment this. Let's put in, how about initialize? Next, we begin being able to use our event dispatchers for what we need. So the events that we're going to base, the conditions we're going to base for when the player finds the keys are when they, in this case, remove the barricades from a house. So what that means is we're going to select the three barricades that are possible to be opened. There's this one, and this one. So here we're going to right click and look for on interaction complete. So we create three nodes. You can see in each one of these events, it lists the name of the actor. We name them barricade 1, 2, 3. So it's clear to us at a glance what's happening when each of these is called. So on barricade complete, we can actually do find actor and level. This is another convenient thing. We can do find actor and level. We only have this on one screen. So there's our barricade. And we can find the keys in this house. This is the fastest way for me to find them is to use the world outliner. Okay, so these are the keys here. Foreman's keys 3. Ideally, what do we name this? Barricade 1. It would have been better to name this. Let's name this key 1. And these Foreman's keys, we want to match them with the number just for clarity of purpose. We're going to call these, since this is barricade 3, we're actually going to call this Foreman's keys 3. So the numbers all match and it's not confusing. It's probably a little easier. And lastly, this will be barricade 2. So Foreman's keys 2. Good, that actually matches. Okay. So now we cannot drive ourselves crazy with mismatched names. It's just good best practice to remember what you're doing. Okay, so I'm going to paste these here. And I'm going to make a potential variable. I'm going to promote this to a variable. We're going to call this possible keys. Every time one of these interactions is complete, it's going to set this variable to the key that's inside the relevant house. So the importance of this possible keys variable doesn't really become meaningful until after the third house is searched in this case. Next, we're going to keep track of two different integers. One of them to keep track of how many houses were searched, and the other how many houses are possible to be searched. So I'm going to set this to integer, name it num houses searched. And I'll duplicate this variable for the other variable we need. And we'll call this num houses max, maximum number to be searched. So we're going to do a simple check here. We're going to count how many houses are searched at this point every time a search or removal of a barricade happens. I'm going to do an increment integer on this. We're going to connect all of these different event dispatchers here. And then we're going to set, let's just, in case we need it, we'll set this variable here. Yeah, we'll need this here because this is incrementing it. So it increases value of numbers of houses searched. And then we're going to compare it to the number of houses max and do a branch check here to see if the max number has been reached. Connect this here and do a branch check on this variable. And the result of the last house being searched is that the foreman's keys, in other words, possible keys right here, will be revealed to the player, not while they're in view, but they'll be allowed to be found pretty much. So we'll do set actor hidden in game. We'll unhide it. We'll keep new hidden to false. And we'll also re-enable the collision so it can be interacted with. Set actor enable collision. We'll compile and save this. Let's just comment all of our blueprint here. We'll just call it control location of keys. And so I can read this a little more. I'm going to increase the size of the font. And I'll compile and save this blueprint again. We also don't want to forget to set a default value for number of houses max. This controls how many houses we want the player to search, how many barricades we want them to open. In this case, it's 3, but if we wanted to change this later to 3, from 3 to 2, or even to 1, we could just change this value. So we're going to change that to 3 and compile and save that. Our next use of the event dispatchers happens when the player has returned to the mill and they repair the gear machine, thereby restoring power to the bridge control switch here at beat 9. So in the level, this is our BP gear machine. We're going to bind an event dispatcher here. Again, we'll make it on interaction complete for the gear machine. And we're going to, once this happens, going to get a reference to the switch here, and we're going to call unlock on it. So this will essentially restore power to the switch. I'll just call this restore power. I'll compile and save this. So the last and final event really of the entire level design plan for this is for when the switch is activated, the bridge control switch. So we're going to make sure this is selected, the bridge control switch, and we're going to right click here and do on interaction complete for BPC switch. And for this event, we're going to use it to drive the extension of a bridge. So let's set up our very simple rudimentary bridge. I'm just going to alt drag this. I'm going to make this a different color as well. Let's make it just a gray so we can actually see it. Okay, and I'm just going to shrink it ever so slightly so that it looks almost like it could telescope inside this bridge. This is some really made up mechanisms right here, but that'll be fine for what we're doing in this proto bridge. Okay, so that's our bridge. One thing we want, if we're going to be moving this thing, scripting its movement, we need to set it to movable. One of the useful things about using the hotkey to show your mesh edges is movable things show up in purple, which is kind of nice. It makes it pretty clear when something is going to be animated or moving. We have that set. It's saved in the right level, Milltown LD, so we can get a reference to it. And let's actually just name it SM underscore bridge. And then back here in the event graph for the level blueprint, we're going to get a reference to that. And we're going to get its actor location so we know its starting location. This is kind of simple interping stuff with the timeline here. That's what we're going to do. And then we'll drag off this, promote this to a variable. We'll call this bridge start location. Connect that to there. Add our timeline. And we're going to lerp the position of the bridge again here. So I'll get my reference to the bridge again. Do set relative location. Update that. Let's do a lerp vector on this to move from its start position to an end position. Let's connect this. And let's see, bridge start location. We're going to make this the initial location here on the lerp. And then we're going to do a small bit of calculations about where we want it to end up. So we'll do bridge start and we'll add vector to vector. And we're going to move this on the y value. Let's see how far we can move it here. If we set this to maybe 100, let's see what we have to do. 12. Looks like 1200 units will do. So we'll set this y to 1200. This is the simplest way you could probably do this, at least in the proto phase, I mean. So we'll create a new float track here for our motion driver. And we'll set the length to, I don't know, 8 seconds, I guess. I'll just zoom out a little bit, create a start point and an end point. And I'll just adjust the handles here to give it a bit of a sense of momentum, and that should be good. I'll just zoom out here and throw another comment box on this logic and call it extend bridge. And one other thing you should always remember to do when you're making a timeline is to connect the alpha output to your lerp vector to make sure it's actually going to move. It's pretty important. So compile and save that. And with that completed, we should have everything we need to playtest the core player progression through the level.